Alright, let's have a look at this one. It's still tech-free, and in this case they've actually sketched the function for you, which will save you a lot of time. Okay, I can see that I have got a graph 3 sine 2x and 3 cos 2x. Okay, they've even labeled that the pink one is g of x and the blue one is f of x. Alright. Now I can also see they've colored in my area. They're wanting us to find the area enclosed between 0 and pi on 2. Just making sure you see, using calculus always means you need to show your integration and show your working. Alright. Now I can see that these two functions intersect at that point over there, and that means I have two separate areas that I am adding up. Okay. When we are finding areas between curves, we don't worry about the fact that some of it might be above or below the x-axis. We're just interested in subtracting the one function from the other. So it's a little bit different to if you were using the difference function. In this case, this is not a polynomial, so let's work with our two separate functions. Notice over here I've got g of x at the top and f of x at the bottom. Here I have f of x at the top and g of x at the bottom. Remember, we're always doing the top function minus the bottom function. And in order to do my integration, I need to find my point of intersection. Okay, so let's start. So again, in an exam, they probably wouldn't say to you, determine the points of intersection. You need to know that that's what you need to do. Okay, so we have f of x is 3 sine of 2x and g of x is 3 cos of 2x. Okay, and we're going to put the two equal to each other. So we've got equation 1 and equation 2. We're going to substitute 1 into 2, and we have that 3 sine of 2x equals 3 cos of 2x. And using our knowledge of trig, it's probably easier to divide both sides by cos and divide both sides by 3, and that gives me 1. But sine over cos is tan, so tan of 2x is equal to 1. And then we need to go back and think about, well, tan of theta is equal to 1 when theta is pi on 4. Okay, so therefore, let's go back to the pink. So therefore, my 2x has to equal pi on 4, and x is going to be pi on 8. Now you need to go back to your domain to try and figure out how many different solutions there are going to be. Notice that we're only going from 0 to pi on 2. Okay, so I'm only worrying about my first quadrant solutions, and x is pi on 8 is in my first quadrant, and I can also see from my diagram that there is only one point of intersection that I'm interested in for this. Okay, so to find the y value of my intersect, so when x equals pi on 8, f of pi on 8 is going to give me 3 sine of 2 times pi on 8, and that's sine of pi on 4, which is 1 over root 2, so we get 3 over root 2, 3 times 1 over root 2, and I'm going to rationalize that, so I get 3 root 2 on 2. Okay, so my point is pi on 8, 3 root 2 on 2. All right, now I can start integrating. Notice I'm going to have my total area is area 1 plus area 2. My first integral will be from 0 to pi on 8. My second integral will be from pi on 8 to pi on 2. Okay, so I start off saying my total area is area 1 plus area 2. My total area will be my integral from 0 to pi on 8. And now I need to decide top function minus bottom function. So g of x minus f of x. And then I'm going from pi on 8 to pi on 2. And let's have a look. We've got f of x minus g of x. Alright. And so now I can work through that. I've got my total area is my integral from 0 to pi on 8. And in this case, g of x was 3 cos 2x. And f of x was 3 sine of 2x. dx, and I want to add that from pi on 8 to pi on 2. In this case it was 3 sine of 2x minus 3 cos of 2x dx. Alright, now we actually do our integration. And you will remember that integrating cos, I'm going to get a positive sign, and I have a linear function inside of my bracket, so I'm going to be dividing it by my derivative of that function. Okay, so we have 3 sine of 2x over 2. And what's your signs? Because here we have a 3 sine of 2x. To get a positive sign, we needed a negative cos. I find it easier to have my brackets there, so negative 3 cos of 2x over 2, and that's going from 0 to pi on 8. And I'm going to add to that, you can put that in brackets if you like. Now, again, we've got a negative 3 cos of 2x on 2 minus 3 sine of 2x on 2, and that's going from pi on 8 to pi on 2. Alright, now when we're substituting in, you're going to find that it gets quite large, right, small and neat. Okay, so we have 3 sine of 2 times pi on 8 over 2, and I can do my minus times minus, so it becomes plus 3 cos of 2 times pi on 8 over 2 minus, remember cos of 0, sine of 0, so 3 sine of 0 on 2 plus 3 cos of 0 on 2. You have to show this substitution. Okay, you've been asked to use calculus. Plus negative 3 cos of, now we're going from pi on 2 to pi on 8, so 2 pi on 2 over 2 minus 3 sine of 2 pi on 2 over 2 minus negative 3 cos of 2 pi on 8 over 2 minus 3 sine of 2 pi on 8 over 2. Okay, I've done all my substitution. So I know that sine of pi on 4 was 1 on root 2. Okay, so I'm going to have, because 2 pi on 8, pi on 4, so I've got 3 times, or 3 over 2 times 1 over, maybe that's the easiest way of showing that, because I've got my 3 on 2 over there, or over there, and my 1 on root 2. Plus, now, cos of pi on 4 is also 1 on root 2. So I've got 3, and that's a 3, that's a 2. 3 on 2 times 1 over root 2. Minus. So sine of 0 is just 0. And cos of 0 is 1. Okay, and then I'm going to add, and let's go again. We have negative 3 on 2, and cos of pi, negative 1, and sine of pi, because 2 pi and 2 pi is 0. And I want to subtract. So here we have negative 3 on 2, cos of pi on 4, which will just be 1 over root 2, and minus 3 on 2, sine of pi on 4, which is also 1 over root 2. If you just keep your head about you and think about each and every single one of them with all their signs, you should be fine. Okay, so now we have, well, we've got 3 over 2 root 2 times 2, so that becomes 6 over 2 root 2. Okay, minus 3 on 2. And then here, negative times a negative, let's just get them nicely together. We have 3 on 2. And here we have negative 3 over 2 root 2 minus 3 on root 2, 2 on 2, which becomes negative 6 on root 2, but then we've got a negative times a negative, so it becomes positive 6 on 2 root 2. And lo and behold, the negative 3 on 2, positive 3 on 2 cancel, and I have 12 on 2 root 2, which becomes 6 on root 2. And I want to rationalize that, so it becomes 6 root 2 on 2, and that just becomes 3 root 2 square units.